everyone, this is the solutions video for our week 5 homework. We are looking at section 5.2.1 in our book. In unit 5.2, we will learn about the inverse of exponential functions. Consider the exponential function of f of x is equal to 2 to the x power. So first it says complete the table for f of x is equal to 2 to the x. So it gives us some x values here that we can plug in for x. So I can take 2 to the negative 2 power, which gives me 1/4. 2 to the negative 1 power, which is 1/2. 2 to the 0 power is 1. 2 to the first power is 2. And 2 to the fourth power, 2 to the second power is 4. Okay, so we've got that taken care of. And then it says we'll use what you know about inverses to make the table for the inverse of this function. So if you remember what we have been learning in class, we just flip our table around. So this will become 1/4, negative 2, 1/2, negative 1, 1, 0, 2, 1, and 4, 2. Then it asks us to graph this. So we've got the original function right here, 2 to the x power. So let's go ahead and graph the inverse. I think I'm going to start with some of the points that don't have a fraction first. So we've got 4, 2, which is right here, 2, 1, and 1, 0. Okay. Then we've got 1/2 and negative 1, so that's like right here. And then about 1/4 and negative 2, so that's like right here. So this graph looks like this. All right. Part D says the y-intercept of f of x is equal to 2 to the x power. So the y-intercept, the point is 0, 1. So what does that tell you about the graph of the inverse function? So if we flip that point around, we have 1, 0. If we look at 1, 0 on our graph, that's the x-intercept. So that tells us that 1, 0 is the x-intercept of the inverse. All right. The graph f of x is equal to 2 to the x power has a horizontal asymptote at y equals 0. What does this tell you about the graph of the inverse function y is equal to the inverse of x? So if we've got y equals 0 as a horizontal asymptote, that tells me that x equals 0 is a vertical asymptote. Of the inverse. Okay, number 2 says find the equation of the inverse of y equals 2 to 2x minus 4. So we need to flip around x and y first. So we have x equals 2y minus 4. And then we're going to solve for y. So to solve for y, I'm going to go ahead and add 4 to both sides first. So that leaves me with x plus 4 is equal to 2y. Then I'll divide both sides by 2. So x plus, I'm actually going to write this just a little bit smaller so I can fit everything on this line here. I've got x equals 2y minus 4, add 4. There we go. And that is our inverse. Okay. Are the functions f of x equals negative 3x plus 8 and g of x equals negative x over 3 minus 8 inverses of one another? Explain why or why not. So let's go ahead and find out what the inverse of f of x equals negative 3x plus 8 is. So I've got, and we're going to go ahead and change this to a y. And then we can flip-flop our values. So I've got x equals, I'll subtract 8 and divide by negative 3. So x minus 8 over -3 is equal to y. All right, so when I see that, these two are not the same here. Okay, the x minus 8 over -3, these aren't the same. So I'm going to write no, they are not inverses. Okay. All right. The function f of x is graphed below along with the line y equals x. So remember, this is like our line of symmetry here. Sketch the graph of its inverse function. So let's take a look. We've got our original here, and then we need the inverse. So let's look at our original and see if we can find some points to plot, or that are already plotted. So here I see -3, 1. I see -2, 3. I see 0, 4. And I see 5, 5. Then we have the inverse, x and y. And then to plot them, we're going to flip x and y around. So we've got 1, -3, 3, -2, 4, 0, and 5, 5. So let's go ahead and plot those points. 1, -3 would be right here. 3, -2, 4, 0, and 5, 5. Okay, so that'll look something like that. All right. And that's all that we've got here. So thanks for watching, and let your teacher know if you have any questions.